Okay, I'm going to make another video here. The other video that I did apparently, well, definitely wiped out the screen at some point, so you couldn't see what I was sharing. And someone had said that they were confused on section 3.2, which didn't have the video or didn't have the textbook up. So let me go through this again, just in case there's some confusion. Okay. So section 3.2, again, we're on the brute force and the exhaustive search. Okay, so brute force, you hit it with a hammer until it gives up, basically. So in this one, the sequential search here, it's going to be for a general searching problem here. So we're going to search through something, okay, through a given list of items of some sort until we find either a match or we get to the end of the list, one or the other, okay? So here's an algorithm through this sequential search here, okay? So again, it implements the sequential search with the search key as a sentinel. The sentinel is a value that will stop the loop, okay? We have an input, which is an array A of n items and a search key K. The output will be the end of the position in A, whose value is equal to K or -1 if it doesn't find anything, okay? So we're going to start here by setting A to N equal to K, okay? And this is a little trick here that they talk about here, that you're appending the search key to the end of the list, okay? So therefore, we don't have to worry about this end of the list check at all. So that's what this is doing, okay? So we're also initializing a value I to our index equal to 0, okay? So we had 0 to n elements. We've now added a new element at the end, basically. So this while loop then is checking to make sure that it's not equal to K. It equals to K when it's at the end of the list, okay? So if it's not, okay, we're going to let I be equal to I plus 1, okay? And, oh, actually, let me backtrack here. It will definitely find K, okay? If it finds K at the last element, okay? So I guess if it doesn't find K at the last element, okay, then we're going to return whatever it found. So let's say we have 10 elements, okay? That are 0 through 9 on our index, okay? So we're going to add, and say we're searching for 7. We're going to add 7 as that index 10. 0 through 9 are the actual numbers of the list. 10 is that index 10, one past the end of our list where we're going to store the 7. Okay, so we're going to go through every element. We know we're going to find K. K is 7. We're going to find it at position 10 if nothing else. Okay, so we're going to check to see, did we find it at some I less than 10? If we find it at 7 or 4, okay, then we're going to return that position. But if we didn't find it until n, we're going to return -1, okay? So that's all we're doing here, okay? And this search is just going to go through until it finds it, okay? So it's not going to go any further past that, okay? So maybe a little whiteboard here would be useful. Hopefully I won't forget to go back. You know how it is. So if we have, I don't know, 6, 14, 3, 4, 2, 20, whatever that is, okay? It's 1, 2, 3, 4, 5, 6. So we have the valid indexes for this being 0, 1, 2, 3, 4, and 5, okay? And then we have our n then is equal to 6. Okay, so we're going to have our A, which is going to go from brackets there, from 0 to 5 are the valid values of that. Okay, so we start, oh, so we also have to have our K. So let's say that our K is equal to, let's say 7. Okay, so the first thing we're going to do here is that we're going to add a 7 here at position 6, which is the same as n, okay? And then we're going to search. So for our search, we start at 1 or at 0, okay? Is that equal to K? No. We move here, no. We move here, no. Keep going. Move there, no. Move there, no. Move there, no. Move there, yes. Okay. So at this point, the I, which was the index value. Okay, these are the I's here. Let me change colors again just to be confusing. The I's here are going in these index values. Okay, so when this terminates, when it finds the 7, which it has to, since we've added that to the end, I is equal to 6. Okay, so then we ask the question, is I less than n? Okay, which is no. So we return a -1. Okay. Okay, so then if instead, let's do a different search. Let's say we're searching for 4. Okay. So we're going to set k now to be equal to 4. Okay. So we're going to start with I being 0 again. Okay, no. Is it there? No. Is it there? No. Is it there? Yes. Okay. This time when it exits, I is equal to 3. 3. Okay. So we ask the question, is I less than n, or I less than 6, or I less than 6? Yeah. Yes. So we're going to return that position 3. Okay. Which means that A sub 3, sorry, yeah, 3. 3 is equal to 4, which it is. Okay. So that's the idea behind the sequential search. Make sure that I share this again. Okay. So this is what we're talking about here. Okay. So we have an improvement here that it talks about, which is often the case, that if we know that the list is sorted, okay, then as soon as we find an element that's bigger than what we're looking for, we know that we're done. I think there was one of the homework problems that addressed that particular issue. Okay. And now I've gone insane somehow. I've lost my way. There we go. Okay, so here's an example of where it's searching for this. No, something else. We moved on. Let me go back. That's the sequential search. Okay, the brute force string matching. Okay, what we're doing here is we have a text T. We have some pattern. Okay, we're going to keep going, keep moving over the first position of the pattern, looking at all the different elements in the text till it finds it. If it finds one, it sees if the next one matches and so forth. Okay. So again, probably an example is worthwhile. So let's go back over to the whiteboard. Okay. So this time, let's say we have really like lava. I don't really like lava, by the way, but you get the idea. Okay. And let's say we're looking for, so this is our text. It's kind of a bad color to see, so let me switch to something else. Okay. And let's say our pattern that we're looking for is lava. Okay. So we start with searching the L here. Is that an L? Nope. So we do the space. Nope. The R. Nope. The E. Nope. Nope. Okay, we're good here. Okay. So we then look for an A here. Sorry, an A there. But that's a nope. Okay. So then we go back to search for an L here again, and yay, it's an L. We look for an A here. Nope, it's not there. Okay. So we drop down to here with an L. L. Oh, there's another L there. So that's good. We look for an A here. Nope. So we do an L here, L there, L there, L there for the space, an L there, yay, an A, all right, a V, and an A. And now we're done. Now we found it, right? But that's the idea. We're going to stop and start, okay? So that's what this algorithm is going to do for us here, okay? So this one is the string matching algorithm it's going to do. So this one's going to implement the brute force string matching algorithm. Okay, so we assume we have this array T of the text. Okay, we have the array P of the pattern. Okay, so we're going to have this loop here on the outside going from 0 to n minus m. The N minus M comes in because if your pattern is 5 characters long, there's no reason to search if you have less than 5 characters left at the end. And that's what that's doing, okay? Then we've got a J going on. Then we're doing a while J is less than M, okay? So while J is going to be tracking how we're moving through the pattern, okay? And then we've also got the and P of J, that position of the pattern is equal to the text I plus 1, okay? So we're going to keep going through that, going to increase, okay? Then if we get the J equal to M, okay, which is a match for that position, we're going to return I, okay? And if not, we're going to keep going and we're going to find that, okay? So that's how that goes. And again, they've got a much better drawn example down here on how this works, okay? Where they start with the NOT, nope, so they go to the N, they don't get it, they drop down again, then do the NOT, all the way till they get here, okay? And that's it. That's all there is to that section. Okay, so those can be a little difficult to deal with. And there's a homework problem there, at least 1 or 2 for sure. Okay, but I did want to go ahead and put this video out there just so you have a better visual understanding. Okay.